Hi everyone! Since you guys are learning about plate tectonics this week, I thought it would be fun to show you how you can use Oreos to model the different plate boundaries that you're going to be learning about. This is a demo that's especially fun for little kids. I saw that there were some elementary education majors in the class, so you might be able to use this in your own classes that you teach in the future, especially if you're teaching kind of the upper level elementary age students. But it's just really fun for everyone, I think, especially when you're able to link food and science together. I just think it's fun, especially because they're Oreos. Everyone loves Oreos, right? So just to give you some, just a review or a little bit of background in case you didn't quite understand some of this. The Earth is divided into 3 layers. The outermost layer is the crust, and it's rigid and stiff. And then you have the middle layer, which is called the mantle, and then the innermost area of the Earth is called the core. So the crust, that outermost layer, is broken up into a series of plates, and these plates move on the surface of the planet in relation to each other. Now they do this because the uppermost part of the mantle is actually not completely rigid like the crust is. The mantle, or at least the uppermost part of the mantle, is made up of this stuff right here, this really cool green rock called peridotite. Now obviously here at the surface this is very rigid, but at depth where it's a lot hotter and the pressure is a bit higher, quite a bit higher, this rock actually behaves plastically. It's kind of like silly putty. And so the plates are actually able to kind of slide around on top of that layer. So I bet you're wondering where the Oreo is going to come in. Well, here it is right here. So if we take an Oreo right here, we can say that the top cookie is the crust, and it's sliding along that more plastic, softer mantle layer. And so to model different plate boundaries, what you can do is break the top cookie here. So now we have 2 plates that can move in relation to each other, right? So if you wanted to model divergent, hopefully you guys remember what that is. It spreads apart, right? So you can show that to your friends or your nieces and nephews or your students maybe in the future and show them, see, the 2 plates are spreading apart and that's exposing that hot mantle underneath. And so in real life, when this happens at divergent boundaries, that hot mantle actually rises to the surface and melts and creates new crust. Now, another type of plate boundary that you can model using Oreos is a convergent boundary. So again, you take your Oreo, break it in 2, and this time, instead of spreading apart, convergent, they move towards each other. So you mush them together until eventually you see what's happened here is you've kind of formed a little mountain range, right? So this is what's happening in the Himalayas, where you have 2 continental plates that are colliding and they're building this really big mountain range. Now the other type of convergent boundary is can form a subduction zone, and that's actually what's happening off the coast from where I live here in Seattle. The volcanic chain and the Cascades are formed because one of the plates is subducting underneath North America and melting in that hotter mantle and creating the volcanic chain here. So the last boundary is a transform boundary. So that's when 2 boundaries are moving side by side like this. So again, you can show that with your little Oreo cookie. They're sliding along that more plastic asthenosphere, but they're not moving away from each other or up against each other, just sliding side by side. So there you go. That is how you can use Oreos to model plate tectonics. Hope you enjoyed my little demo. Now my laptop is covered in cookie crumbs, but it's okay because I love Oreos. Hopefully you guys have fun this week learning about plate tectonics and about how to use Google Earth and about kind of the basics of hazards. Again, please email me if you have any questions or comments, or post to the discussion forums, and we'll keep in touch. Thanks.